Thank you very much, and thanks to Hope for having us. We're really excited to do the talk. My name is Kevin Carter. I'm a technologist, and writer, and artist living in Brooklyn, representing here. Yeah, I'm going to be kind of doing a quick overview of of mesh networks, and then we're going to get down to the nitty gritty with the people who actually know what they're talking about here. I'm going to let these guys introduce themselves too.
Sure. Hello.
Here.
Oh, I got to turn it on. Hello. Okay. There we go. I'm Peter. Along with Kurt, we run the NYC Meshnet meetings. So if you go to nycmesh.net, you can see us there. We're basically just a group of people who are trying to get a wireless meshnet set up here in New York City, and we think it's a good opportunity because it's as dense as any city will be. And if we can get one set up here, maybe it'll set a good example, and we're just hopeful. So,
I'm Kurt Snekis, and pretty much the same as Peter, just trying to set up a mesh network and see if we can create something that, is community-based and allows people to connect to each other.
Great. So we're going to go ahead and get started here. I guess one of the questions that people have, why fix it if it ain't broke, right? I mean, we've got the internet, which is one of the most phenomenal innovations of the 20th century. And that's an understatement somehow. We've got this incredible network that runs our world now. Why should we build a new one, right? So I wanted to kind of go through some of the issues with the architecture that the internet operates on right now. As you guys know, the internet, ARPANET was first built by hackers, right? It was hackers, it was academics, it was engineers, working for the government who designed the internet. And because of that, because they're just trying to get an operating network, they're not anticipating the incredible growth of this. So it's not their fault. They're trying to get things up and running. They've done their job in making sure that there's a way for these groups to communicate. And you can see here, this is the Tech Model Railroad Club at MIT, 1969. So these were the guys that were building it. And this is a map of ARPANET in December of 1969. You can see this is what the internet used to look like, the architecture, right? So you can see, Utah, UCLA, UCSB. I mean, we got, that's all right. We got 4 nodes on the network at this point. So, and this was 45 years ago. So, I mean, we've done, we've done the unimaginable in building the internet. But there are some architectural issues that we're addressing today. I'm going to go over those briefly. So, with the growth of the internet, things have shifted dramatically, right? We've seen political and corporate control of this network that was originally designed to allow academics to, engage in the free flow of information. And more than that, we've also seen corporate control of the network, right? So here's a quick map of ISPs right now, state by state. These are the top ISPs in each state. You can see Comcast, if the Time Warner buyout is approved, Comcast will be the top ISP in 26 states, right? So, do we want Comcast controlling the entire internet is the question. And you can see here, it's all about lobbying. It's all about these enormous, multinational corporations using their power, economic power and political power to determine how the network is regulated right now. So that's a serious issue. You can see here, kind of doing just state of the internet, right? There are some serious threats to the internet as we know it today. You guys have heard over the last few days, net neutrality has come under fire in a serious way. We have an oligopoly of ISPs who control the network in a terrifying way. And we also have the surveillance state, and that's both political and corporate. As hackers, I say as consumers and technologists, but more importantly as hackers, we have to make sure that the original vision of the internet's architects stays pure. We want to ensure that the network is democratized, that it's decentralized, because otherwise this might happen, right? This is a theoretical, plan for the internet if net neutrality fails. So we've got, $5 for a Pathfinder plan where you can, subscribe to search engines, and $10 for a Hollywood plan with YouTube Plus and Hulu and ESPN. So, this is one of the things we're trying to avoid. Like I mentioned, net neutrality is facing an immediate danger. It is incredibly problematic that these 130,000 filings, and in fact, this was taken a couple weeks ago. I think it's considerably more, have had to take place, and it's because the FCC is the FCC is part of the political system, right? I mean, these lobbyists do control the administration's policies, and this could mean that ISPs don't have to abide by net neutrality. They claim that that it's not going to be an issue, and yet this fast lane is going to make slow lanes for everybody else. So, ironically, also, as long as we're talking about this, when the FCC asked for comment on this issue, the number of requests, to comment on it broke the FCC's server at the time. So, maybe they should have paid for a fast lane. Who knows? I don't know. So another issue is the ISP oligopoly, right? We've got control of the internet in the hands of very few companies, and these are companies that have used government resources, our tax dollars, and promised that they would build the next wave of infrastructure in this country. That has not happened. Fiber optic cable was supposed to be run countrywide, and all of a sudden they were just like, maybe we're going to use those resources for something else, raising executive pay, for instance. So, I mean, when you look at this breakdown, this graph illustrates it perfectly, right? So in yellow here, you see the speed of the connection in megabits per second, right? In blue, you see the price that these customers pay. Take a look at South Korea, 100 megabit a second download, and less than $20 a month for internet connectivity, but on average. If you look at the US, all the way down here, we're talking 50 megabits and, average price of, $90 a month. So, I mean, you can see this really illustrates that we are not getting what we're paying for in terms of internet. And, it's an issue. You can see we're number 29 here, just above Estonia in terms of average, average bandwidth. That's nothing against Estonia. I'm just saying that, a country with the infrastructure that the U.S. has, and, the number of, the number of incredibly talented engineers who have built this network in this country, we should be able to average more than 25 megabits. The third issue that we're dealing with here is the surveillance state. And like I mentioned, this is political and corporate. I mean, we've got issues with the NSA, the CIA, these governmental agencies who are, conducting, I mean, what are essentially attacks on the infrastructure technologically of this country, for political gain. And we've also got corporations like Google, Facebook, and Amazon who are actually making it their business to ensure that your private data is no longer private, right? So when you're not paying for something, you are the product, right? You are the product that they're selling to advertisers. And with the centralization of the internet as it exists today, we are getting, I personally am getting concerned about the state of things. Here you can actually see the NSA TAO or TAO unit intercepting Cisco equipment. So actually, when a router is being mailed out to a company, they will actually unpack it, in some cases, they will put in their own surveillance hardware and then ship it as if it was coming straight from the factory. So this is one of the photos that was released in the Snowden leaks. So, going over these concerns again, the end of net neutrality, we've got an ISP oligopoly, and then we also have a corporate and political surveillance state. So, the original design of these engineers who were very utopian in their thinking, their architecture is brilliant, but it does not address the problems with the current internet. So, what I want to talk about next very briefly is just the concept of a meshnet, and how we believe that meshnets can address some of these concerns with the current state of the internet. So, as you guys know, wireless technology has become ubiquitous. You see wireless routers everywhere, and routers that would have cost thousands of dollars years before, you can get for $30-35 today. So one mesh network that we're going to talk a little bit about today, and it is by no means the only mesh network, but it is the one we're going to be addressing today. It's called Hyperborea, and it's a current popular network. So let's do the definition, which is very critical to understanding this. A mesh network, or a meshnet, as we're abbreviating it here in the presentation, is a network topology in which each device is connected to other devices on the network, and it directly relays information throughout the network to its peers. So essentially, a mesh network is this network where devices are connected, they're sharing information, they're routing traffic, and the reason for this design is because it's not top-down, right? This decentralizes the nature of the network. You can see here that it's named after sort of a mythical land called Hyperborea, which has been said to be geographically in different places throughout history. Just quick anecdote. This is a map of a theoretical Hyperborean ocean back from 1572. The reason I want to show you this map is because this is what Hyperborea looks like today. So this was a screenshot that I took on July 5th. You can go to fcc00.org to see more, and you can actually see a live picture of it. But I just wanted to briefly show you guys that these are all the different nodes in the network and how they're connected right now. So let me go over Hyperborea briefly, and then I'm going to let these guys kind of go over some some of the technical sides of things and talk a little bit about mesh networks. So Hyperborea, I figured, why reinvent the wheel? They've already done a great job of defining it for us. It's a global decentralized network of nodes that run CJDNS software. And CJDNS is a network protocol that we're going to go over in more detail later. But the goal of Hyperborea is to provide an alternative to the internet with the principles of security, scalability, and decentralization at the core. Anyone can participate in the network by locating a peer that's already connected to it, right? So we've got security provided for by this new protocol. We've got scalability because, as you can see, this is already a large network, and decentralization, most importantly, so we can get the network out of the hands of, the rich and powerful. So, like I mentioned, the protocol that Hyperborea, for instance, runs on is an open source protocol called CJDNS, created by Caleb James DeLisle. The software uses public key cryptography to encrypt data, so that way we can ensure security and privacy, right? One of the issues with traditional network architecture is that there wasn't security built into these protocols. We had to build in IPsec later on. We had to build in DNSSEC later on as just a way to kind of, it was a kludge. It was a way to use the old architecture and get past some of these issues. And these were brilliant innovations by brilliant engineers. But at the same time, we have to start addressing the issues. HTTPS, right? I mean, we've seen some critical failings there lately as well. So, right now we're looking at new ways of doing things, and CJDNS is a great protocol because it provides all of these aspects, right? Decentralization, security, and privacy. Like I mentioned, though, CJDNS is by no means the only way to connect, right? So just to review, a meshnet is the topology, CJDNS is a protocol, and Hyperborea is a network, not the network, but a network. So CJDNS isn't the only way to connect to a meshnet. We're using it because there are security and privacy benefits to it. I mean, and that's what we're using, in the NYC Meshnet project. That's what the Seattle Meshnet project is using. But we want to make it clear that we're protocol agnostic. We're just talking about meshnets in general. Another one is Batman, which is the better approach to mobile ad hoc networking. You can see here. So briefly, want to go over decentralization again. The reason that decentralization is so important is because it gets us away from the traditional tree topology of an ISP model, right? So these meshnets with CJDNS allow information to propagate throughout the network using the different nodes that are on the network. It's managed by the users and for the users. So, I mean, this is really a hacker network right now. You don't call up Time Warner or Comcast and have to, go. You guys heard the Comcast call that's been going around, I'm sure, with trying to cancel service. You don't have to call up your ISP anymore. You do have to know how to use Linux, but basically, the reason that we're suggesting to move toward decentralization is because of the ISP oligopoly issues and because of the socio-political issues that the current state of the internet has caused. I mean, you take a look at Syria, Egypt, right? I mean, these countries shut down the internet when it didn't serve the political purposes of the leaders. And this could very easily happen to the internet as well. Under martial law, or if there was some kind of political crisis, there is actually already law on the books, the Communications Act of 1934, that the government could theoretically say, well, let's shut down the internet, right? Let's shut down the main DNS servers. And what decentralization does is it puts the power back in the hands of the users. Finally, let's talk a little bit about security and privacy. So, like I said, security in CJDNS and on Hyperborea is designed to be, quote, ubiquitous and unintrusive, like air, right? Part of the problem with the security protocols that we use today is they're difficult to use, right? I mean, when you talk about PGP or something like that, right? It's an incredibly powerful encryption tool. At the same time, because it's difficult for users to use, it's difficult to understand exactly what's happening. It makes it so that people don't use it as frequently, and everything's going out on the ClearNet, right? Everything's going out in clear text instead of encrypted. What CJDNS does is uses, the idea of security being ubiquitous, being unintrusive. It's a layer of abstraction, right, that the user never has to deal with. So it stores its routing table in a distributed hash table. Like I said, it uses public key authentication and stack smashing protection to make sure that buffer overflows are prevented against. So people have really gone into security in a serious way in designing this protocol. That is another benefit that CJDNS has. So I'm going to kick it over to Peter and Kurt here, and they're going to kind of go over some additional aspects of Meshnets.
Yeah. So I guess I'll just talk a little bit about the more technical details on CJDNS. So it's basically, at this point, this guy designed a protocol and he wrote a software package to run the protocol so that you can connect nodes together with it. So it's he took basically a private subnet from IPv6, FC00/8. It's like a lot of addresses there, and then to get there's a security layer. The connections are all encrypted, and the way that is accomplished is with public-private key encryption. And that's actually tied to your IPv6 address. So when you connect to someone, you get their IPv6 address, and that's their address because it's the beginning of their public key. And that's how you connect to them, establish that connection. So the CJDNS gives several benefits: the security layer on the actual network layer, and the trust that you get from the public and private key and the IPv6 address they have. And what else?
Well, okay, so two of the major parts. So one part that Kurt just talked about was address allocation. So just to be a little clear about how the private and public keys are tied to your IPv6 address, when you're generating your configuration for CJDNS, you are generating your public and private key pairs, and you do it until you're able to basically, through some transformation, have your IPv6 address be a representation of your public key. So it's not like there's some database somewhere that just maps IPv6 addresses to arbitrary keys. Your IPv6 address is, in fact, truly a representation of it. So once you receive any sort of message claiming to be from some IPv6 address, you can very easily verify it, which is a major flaw of the current internet. or the old internet, as we like to say sometimes. And so that helps basically any form, any data that's passing through it. It's signed by the person who's sending it, and then using the public key of the person they're sending it to. Every piece of data that flows through the network is encrypted. It's not added on top. It's not some protocol built on top of any other protocol. It's just part of the CJDNS protocol. So at a very low level, security is just built in. So that's kind of that whole AIR, security ubiquitous quote. So it's built in from that low level. And additionally, it handles routing. So this is kind of the major problem that people tend to bring up when it comes to meshnets, is that routing becomes very hard because now it's just one big flat address space. There's no sort of hierarchical way to know, like, okay, these addresses are all in the US, these addresses are all wherever. So it has some sort of routing algorithm built into it that does prevent several things like routing loops and things like that. And it uses a distributed hash table to sort of store and keep updated routes throughout the network. And so it is one of the major problems, and that is one of the things that's often brought up, but it handles it pretty nicely. And I guess we want to be clear that CJDNS isn't we're not necessarily dedicated to it. It's the protocol that we use. There are several out there, but that's the one that we're working with for the time being. So if one day we decide, okay, CJDNS isn't going the way that we want it to, or for whatever reason it just doesn't work out, we're ready to move on. This is more about getting a meshnet set up. It's not about sort of selling you a specific software suite or something. We just want to build a meshnet that works. And right now we're using CJDNS because it handles routing very nicely and has security built in at a very low level. So that's very nice. Additionally, a lot of these other protocols work over the IP layer, whereas CJDNS works with Ethernet frames. And so if we're just connected via some Ethernet cable or something, or we're just associated and not even any DHCP handling on a Wi-Fi network, you're able to connect to each other just via pure Ethernet frames, and CJDNS handles that. So we don't have to build any sort of kludgy thing on top of IP. And I guess for CJDNS, that's about it. So that's what we're using currently. What else do we want to talk about?
So I guess wanted to also do kind of a brief tutorial, right? So I mean, you guys are hackers, you're DIY makers, you know, whatever you call yourself, whatever label you use, you want to know how to do it, right? You want to know how to get connected. So we wanted to kind of do a quick tutorial. I was in the same place, right? Before I met these guys, you know, I was kind of like, listen, I've heard about meshnets. I want to connect to one, but I don't know what hardware to use. I'd like look online, and people were like, well, you could do this, but we don't recommend that. So you know, these guys built an excellent framework when they were working on peering on NYC Meshnet. They basically kind of created a guide. You know, this is kind of a how-to on how to peer. And so, although there's not an official kind of router that you need to join the network, you know, Project Meshnet in particular recommends something like the Ubiquity NanoStation or another OpenWRT compatible router. Obviously, this depends on the situation. You're not always going to use a long distance router, but it is something that, you know, it's going to broadcast further, more people around you can connect. So it's kind of a nice, you know, nice way to do it. Again,
right, and this is kind of sort of chicken and egg-ish type problem, that if we want to get a meshnet set up, it's all based on having people near you that are on the meshnet, and that's what makes it easy to join. So when you're establishing one, you don't have all those users that make a meshnet what it is. So that's why in the beginning, hopefully eventually in the future, we can move to sort of not as sort of high-powered routers, you know, and having to use directional routers that you point at people and figure out where they are. Hopefully you can just use, you know, any little standard home router. We'll go over what these are, but these are just, you know, little $40 routers that you can get $35 on Amazon. And hopefully what we'll be able to do is that people can just use these, but for the time being, when we're setting up a meshnet, we need some sort of, I guess you can call it like a backbone, where we're able to connect the sort of pockets of meshnets that are going to start appearing as you establish a network, because we're not just going to all be grouped near each other, and otherwise we just use some switch and just all connect to each other. But we need somehow, some way to get the whole city connected in the beginning. And so that's why for the time being we're using these nanostations, which can broadcast for several miles away. Last year, until Kurt moved, we had a link set up not terribly far, but I'd say like 1.5 kilometers away from my window to his building's rooftop. And he was able to access the experimental network, or rather I was able to access Hyperborea through him. So it works, and so that's why we're moving forward with it. Again, just like CJDNS, we're not necessarily sticking to any piece. This is what works. How fast? So of course, this is one big question. How do these networks work? Our connection at that time was, there was a building in the way, so it's kind of amazing that we were able to get connected in the first place. And so it was a pretty flaky connection. So as far as that connection goes, I can't really tell you. But we do see, when we set up the little like local mesh, like mini mesh nets at our meetings, which are several people on it, we'll get I don't know, a few megabytes per second. Just at the bottleneck not being necessarily CJDNS, it's more what the hardware that you use. So if we want to establish something stronger later on, we can. So I just want to keep reiterating the point that this is about mesh nets. We're not sticking to any piece of the hardware. We're just saying, if you want to jump on, this is what we're working with right now. You can use these things, but we may change it for better things in the future. We're not, because a lot of these movements tend to get stuck when they stick to certain things and really try to make it get working, but if they don't work out, we're going to move forward with something else. So, but for the time being, these are working great, so don't let me say like, oh, I'm not sticking to them. We have been using these and they work just fine, so don't be afraid to buy it. Don't hesitate. They work, but just a heads up.
And yeah, I mean, I think that's a great point, Peter, that we are vendor agnostic in setting this stuff up. We're not trying to sell you on a Ubiquiti router. If something else works better, use it. If something else works better than CJDNS, use it. But just in talking about mesh nets, this is what we're using because it does work right now. So the great part about this is that NanoStation, that's a really long distance router, it's only like $80 online, right? You can buy it easily. You can also the whole kit that is kind of set up right now, and that these guys have put together just as a way to get things going. It's only about $150, but if you've got the parts already, like if you have a Raspberry Pi already, you're talking about $100 for the setup. You don't have to buy that router either. You can use a router that you've got laying around the house. You could even use one of these cheap little $30 router, battery powered. You can set that up too. But this is the basic setup, right? So NanoStation M5, which will allow you to broadcast a mile, right, or around that. You can also run it on a Raspberry Pi right now, $40 online. And if you need like the SD card and the power supply and all that stuff for your Pi, most people already have them. But if you're just buying one for the first time, all in, you're talking about $30 for that stuff. So there's actually a link, and it's just nycmesh.net/blog/starting-with-the-basics. But if you just go to nycmesh.net, you can get a link from there. Also, if you're looking for a copy of the presentation too, later on, because this whole thing is online, you can go to tinyurl.com/wireless-meshnets. So tinyurl.com/wireless-meshnets, and we'll have the presentation up there so you can take a look. But this is the Raspberry Pi Model B. You guys want to talk about Meshberry a little bit?
Yeah, I'll talk.
Yeah, sure.
So Meshberry is an image that we've made available online that has CJDNS basically one command away from being set up. It's very close. It uses the Raspbian image. It's not like some really custom thing. It just has Raspbian and then a couple of other things built on top. We pushed the kernel version up a bit just because we needed access. So all of this is IPv6, so we needed IP6 tables, and there's certain things that might make it hard to get a Raspberry Pi set up if you're just trying to jump in. So we made this image available online. You just run SSHN, you run 2 scripts, and you're able to, one, have CJDNS running, and on top of that, CJDNS currently only works on most Linux machines. Mac almost completely functional, missing a few things, and a Windows version is just on the way. And so for the time being, what we're doing is you're able to use any of the devices that we have, but in the Meshberry Pi image, we have set up like a NAT script that'll, once you run it, as long as it's on your network, any device connected can connect to Hyperborea and access any of the services or websites that are up there. So if you go to the NYC Meshnet website and you're interested in getting CJDNS installed on your Raspberry Pi, it's available for download. You just download it, flash your SD card that you're using, SSH in, run 2 scripts that are right in your home directory, and you're ready to go. You just have to add a peer who is connected to Hyperborea, and you have access to the entire experimental network. So we have that up online for any of you guys who want to work with a Raspberry Pi, and it works quite well.
Basically, these guys have done the work for you already. Like, you don't have to figure out how to compile the, like whatever. Like, you don't have to mess around that much. You basically just download the image, nycmesh.net/meshberry, and then you're up and running. I mean, you run these scripts. It's really easy to do. So, that's the Meshberry philosophy. So, do you guys want to talk OpenWRT at all?
Yeah. So there's another project called Meshbox, which is a group of people, I think it's the Seattle Meshnet people, trying to get CJDNS working under OpenWrt. And they've built actually, if you've ever used OpenWrt, they have the nice Lucy interface, and they've got graphical configuration stuff for CJDNS there. I think we have it over here somewhere. Yeah, this one. So this is like this Meshbox thing. So here we actually have a few. This is sort of a demo too. Yeah. We have a few routers running OpenWrt, and they are connected to each other. You can see that this is the IPv6 address, which is, and so if you go over here too, you can see, let's see, things like the public key and the private key. Don't look at this. This is a secret. You can't see the whole thing, so it's okay.
Yeah, it's obscured. It's okay. It's been redacted.
I'll just reflash it later. And so this, I don't know. Did we talk about? There's 2 different interfaces with CJDNS. There's this UDP interface and Ethernet interface. So the Ethernet interface is pretty great because it just sort of sends out beacons, and anything else on the Ethernet network that receives them and is running CJDNS will respond, and they'll get connected to each other, and you don't have to configure anything. So that's kind of what we're trying to do in a city mesh network, mesh local, so that it's just completely like there's no configuration required. Everyone can set the thing up. And then there's a UDP interface thing, and this is over UDP packets, but you can run it over the old internet on IPv4. Which is how Hyperborea is currently set up. So it's people connecting to each other by giving each other their IPv4 addresses and configuring it. But hopefully in the future it will be all configurationless.
Yeah. So I guess this will be a good point to sort of lay out really the basic steps, because we're alluding to certain pieces of the software, but really maybe it's terrible pain to set up, which it's not. So let's just go over the steps, I guess, right now. So let's say you want to get, in the typical case, like let's say moving away a bit from the nanostation case, the more typical case will hopefully be with just like a typical plain old router that you can just whatever flash OpenWrt on. So we have the image, and we're going to make it available online soon once we work a thing or two out. But all you have to do is you get the image, you flash your router, okay, and then once you do that, you go and you just connect, you make an ad hoc network, and then so the reason we're using ad hoc networks and the reason we're using OpenWrt is because ad hoc networks allow people to connect to each other without anyone sort of being the master and being a sort of central point. So you set up an ad hoc network, and then you tell CJDNS to listen to that interface, and that's it. And what will happen then is that through these Ethernet frames, CJDNS will just automatically find the people who are also on that ad hoc network and automatically peer with them. So it's just getting the ad hoc network set up, and once CJDNS is up and running and built, which it's already pre-built into these images, you just have to tell it, listen to the wireless interface, which is just one line, and that's it. It starts auto-peering. So it's, pretty close, as close to zero configuration as you can get for now that we've seen with any wireless network is you just get the wireless network set up as long as you're associated with other people. You tell CJDNS, listen to that wireless interface, and it handles everything else for you. And so from that point on, you just need to know people's addresses. And so these are the kind of things that we eventually want to move forward and make, because things like DNS and all these other services that are integral to the internet right now and allow us to find other websites and other people don't really translate so nicely to Meshnets. So if anybody wants to be famous, you can work on a DNS solution for Meshnets. There are some out there that, are viable contenders. There's things like Namecoin, which handle a sort of like a decentralized. Yeah, sure. A round of applause for all these Bitcoin cool things happening. But it uses the blockchain, as do so many other things. But it uses the blockchain to essentially act like a distributed DNS, and you can just look up things on the blockchain and know where to go. Interesting solution. We're not sure how necessarily we feel about it, whether we're going to move forward with it, but it's one of the bigger problems that have to be solved for these kind of networks, because now we're moving away from central authority. And moving away from that means that somehow we need to mediate who's who and where anybody is. So if you want to know what name maps to what, right now there's no clear winner. So if you want to work on that, thanks.
This may be the first time I've been on a panel where the demo is actually working. So you guys are just asking too much. Like having security and the demo working at the same time? Nah. Do you guys want to talk maybe briefly about kind of how else people can get involved?
Yeah, I guess also with this interface we can show.
Yeah.
Show them just where you tell it to listen to the wireless interface. So that,
Which one?
So they believe that it's not hard.
The peer
settings.
thing?
Settings,
Okay.
yeah. And then at the bottom.
Show them my IP, my private key again.
Don't look. Okay, so, you can tell. Okay, well, it's at the bottom there. Ethernet interfaces, so all it is, those two interfaces there, it's just saying, hey, listen to br-lan, which is the open words sort of like Ethernet, like physical port interface. And then we're also telling it to listen to WLAN 0, which is the wireless interface. And if you tell it to accept and send beacons, it's going to handle everything for you, as long as if you're wired up to somebody, you don't even have to have any sort of internet or IP configuration set up. If you're connected over some Ethernet cable to two CJDNS-enabled devices, because they work over Ethernet frames, you don't need even static IPs or any IPs to be assigned to any device, as long as they're able to get Ethernet frames to each other.
Yeah, this is the view of the Wireshark showing you the Ethernet frames pretty much going by on this network here. The Ether type is FC00, and it's just filtering on that. But yeah, you can see they're all just talking to each other.
Yeah, so I guess we'll talk now about now what we're actually doing besides just the software. We have weekly meetings where we meet virtually all Sundays. We may change it, but anyways, it's Sundays for now. And we meet in the Lower East Side at a cafe. It's kind of like revolutionary seeming basement. Kind of hipstery, but it's not that bad, I promise. And we meet there, and we help people who are new get set up, catch them up with what Meshnets are. People buy their hardware. If they're having trouble flashing it, we'll flash it for them. And so what we're doing now is what we just need people to do is get these devices and basically start peering with each other. The software is just about ready to go. We have these openWrt custom installations that you throw them on, add that line, you saw that line where you just add those two interfaces, and they start auto-peering. And so the software is there. The issue is now is getting people who are interested and who are kind of technically capable. You don't have to be necessarily, I don't know, a ninja or whatever people call themselves these days. You don't have to be that good. You can, especially if you come to the meetings, we're there to help you out. We're there to get the flashing happening, and now there are nice little GUI interfaces where you can configure everything. So the software is all there. So what this means is that we need to find people, and so this is the harder part. Like I said before, kind of chicken and egg problem, where the whole Meshnet idea and concept revolves around lots of people being near each other and connecting to each other. So now we need to get those people who are going to do that.
Yeah.
So we have a few things. So we have those meetings for people to come out and find people near them. We also have a map up online that's using some software that was built by people in the Project Meshnet community that help us sort of map where people are, and you can put whatever other information you want there. So you see that we do have like little groups. You see those like little cluster green nodes where we have little pockets of people in different places. Like in Astoria, there's a few people. So if any of you are in Astoria, if any of you are around Park Slope, Lower East Side is where I am. So if anybody wants to be my peer, that'd be cool. But there's a few pockets, and so what we imagine is that people are going to start getting peered there, and then we're going to use these long distance ones to sort of then connect these longer distanced pockets. So we just need to find people, and we're trying. So if you want to come join our meetings, or you know people who are interested, or you want to jump on the Meshnet for fun, you're welcome to come to our meetings, nycmesh.net. We're on FNet. A lot of people don't seem to like FNet. I don't know why, but we're on IRC, on FNet, if you dare come. And we're always there. We're idling, you ask any questions, you have any trouble, we're more than willing to help out.
So just wanted to put this up just so you guys can see the actual URLs and stuff. So yeah, well, like Peter and Kurt were both saying, I mean, Hyperborea is a global network, but you can join an individual meshnet. It doesn't have to connect to Hyperborea even. You could just have a local meshnet. Yeah, these things are called mesh locals, and you can join up with them in in pretty much whatever city you're in. So I mean, some of the big projects right now are Seattle, here in New York, like we mentioned, Washington, but they're happening everywhere. You know what I mean? So you can go on projectmeshnet.org. You can find a list of mesh locals near you. If you're here in the city, like these guys are saying, check out nycmesh.net. It has all the meeting information up and how to connect there. Also, if you don't have a mesh local, let's say you're in, you're in a city that doesn't have one, start your own. That's what these guys did. So you can. There's actually a pretty good tutorial on projectmeshnet.org on how to start one. So that's a big part. If you want to get involved, either start one or join one. Also, developing services, like Peter was saying, DNS, it hasn't been fully solved for Meshnets yet. So, try building your own system. Try playing around, especially if you're a developer. You know what I mean? Make it so that people have cool stuff to do on the network. And then here are some links to some of the places we were talking about. There are subreddits about this. Actually, the Hyperborea kind of started on, but we're kind of moving away from that particular subreddit. So there are also like we mentioned Meshnet users who are on IRC, on FNet. You can check out NYC Meshnet, Project Meshnet, CJDNS. All of these are kind of ways to get involved if you want to learn more. So.
Yeah, so I guess we'll go to questions. Thanks for listening.
Thank you, guys.
Lights, please.
The FCC, they allow higher transmit power for specifically point-to-point wireless systems. It's like 4 watts EIRP versus just the regular 1 watt that we are allowed to use with Wi-Fi. So that means that you specifically need one partner. Is there any kind of like database of like people looking to peer with one other person for those higher like single links? Are you using those, or are people doing that now with the mesh or with your mesh?
What's mostly happening now is people are using Wi-Fi mostly because they want to leave it open for other people who then find that there's a node near them and want to jump on. They can jump on that network as opposed to using just the straight one-to-one links. Right. But no one's opposed to it. So if you live somewhere and you want to connect to one other person, you're more than welcome to. There's all kinds of setups, and I think that was the point that we were trying to illustrate, that this is what we're suggesting, but honestly, if you want to use smoke signals and have CJDNS somehow, I don't know, use OpenCV to like grab the smoke signals, then you can do that. That's up to you. If you want to build that, you can. How you make the link doesn't matter. If you use an Ethernet cable, you use Wi-Fi, you use direct links, it doesn't matter. So you're more than welcome to, and you can jump on IRC if you want to find somebody.
Okay,
Yeah.
so it's not like you have a database online, so,
Well, the-
hey, I want to peer with somebody.
This
Right now
map
we-
is pretty much
Yeah,
like
yeah.
these are people that are interested in peering. So if you found someone close enough to you, you could talk to them
Awesome.
and
Cool.
try to
Thank you.
work with them. Yeah.
Yeah, thanks.
Thanks, Peter.
How close is this to actually being fully functional as a replacement for a local network? Specifically, if I connect to this mesh local, how do I get out to the old internet?
So actually built into CJDNS is something that allows you to basically put someone's public key in, and you're able to provide your internet over CJDNS to them if you're connected to the internet. So let's say I have some private server somewhere, and you give me your public key, I can provide you my internet over CJDNS, and that's built in. So that's one of the steps that we can move forward, is that if you want to sort of gain traction for this new network, we can provide this sort of transition service, maybe provide access to the old internet while still bringing people to the new network. And that's built right in as well. So if you wanted to do something like that, you could, and you can use it for a local network as well. It works just fine. So. All right, cool, thanks.
Hopefully a very quick one, but the eventual goal of the Meshnet will obviously be to completely avoid any use of existing ISP infrastructure and any corporate controlled structure, and that will obviously work particularly in a city like New York and also other urban areas, say along the East Coast. But obviously there's going to be problems with, say, intercontinental links through to the UK, Europe.
Right.
It's going to be quite difficult to run a wireless link without using some form of corporate infrastructure. So,
Right.
what sort of way around that problem might you be able to?
I mean, one thing that we're thinking is that, ideally and hypothetically, as the Meshnet moves forward, the internet will become more of a backbone. And so hopefully, someone's going to need to bridge that gap, and it's going to be some organization. So the idea is that we'll have some trusted organization somehow bridge that gap and be just like the backbone that connects mesh locals, as opposed to having everybody on that network. It's more just to connect city to city. And so hopefully, I think there's no way to avoid having some sort of organizational structure handle that, but hopefully we get a good
No,
one.
that's good. But another thing I wanted to quickly put in is because the first person to raise a question did raise FCC regulations,
Yep.
which limit transmission power. Now, is there a possibility that in the future, if they find that Meshnet's too much of an organisational headache for them and they are losing too much control, might they actually change the standards to reduce legal transmission power, meaning that Meshnets either have to become more dense to remain functional, or basically meaning today, if you can use 4 watts of transmission power, you can go for, say a few miles. But if in future they reduce that permission down to say half a watt, or 1 watt or half a watt,
Yeah.
that will reduce the distance significantly, thus breaking some of the Meshnet system.
It's hard to say what they'll do in the future. There's no sort of hint that they're going to be necessarily strict. These rules seem to be kind of stable-ish for now, and I haven't heard any rumors of lowering power restrictions. But we're not too worried on that front. And if it happens, we'll work something out. That's the cool part. We're not dedicated to any one piece. We'll solve it.
Brilliant. Thank you very much.
Thank you.
Questions abound. This was a wonderful talk.
Thanks.
I'll stick with a technical question. Those are the easy ones, right? So you're talking about CJBNS. This
Yeah.
is a piece of software that has 3 flaws that are serious problems for the security-minded. It's written in a very unsafe language. It is based on a white paper that has not been peer-reviewed, and it uses cryptographic primitives and constructs that have not been peer-reviewed. Rather than frame this as this sucks and you shouldn't use it, I'm going to be positive. What kinds of improvements are in the pipeline such that the software can be considered safe for those of us that care about security?
Well, okay, so CJDNS, it's the piece that we're using, but we're not necessarily terribly involved in its development. It's a guy named CJD, very smart guy and a very cool guy from what I hear. He's written most of the library himself. And so as far as reviewing and getting other people involved, there just haven't been many other people jumping in and getting involved with it. So
There's about 30 developers, actually, they all are constantly fixing bugs.
well, okay, I mean, okay, involved in its development, but I mean, I think, yeah, well, we can talk after if you have an issue with anything I'm saying. But originally it was, to go back to you, and so what's in the pipeline, I can't say we necessarily know, because we're not actively involved in its development. So, okay.
But I would say too, like, it's the protocol. If there's flaws in the protocol, I'm sure Caleb would want to fix those. And then if there's flaws with the software, you can, write your own
And that's definitely
software
part of,
that uses the same protocol.
right. I mean, that's definitely part of getting involved in this too. If you are a developer and you see issues with CJDNS, like let those developers know. Try to help patch them. That's kind of the open source spirit, right? If if you see something that's broken, it's every user's goal to try to be a developer if they can and try to fix those issues. But we're also not protocol. We're not trying to say use this protocol. It's it's one protocol we can use. If somebody writes a better protocol, or if there's a better one already out there, even better, right?
Okay,
But
so
it's
yeah, I guess we're about done here. So if you have any questions or want to talk after, you're welcome to come up. I'll be in the back. We'll be in the back. Thanks. Okay, all the way out.
That way we don't
in the
crowd
back.
the room. Thank
Just
you guys
look for
so
me.
much.
Thanks. Thanks for coming.
Yeah. Hi, everyone, and I hope you're having a super duper day, because I sure am. This has been a spectacular program, and we're only on the first day. It's going to get better and just stay alert and plan on spending some long hours, long days, long nights. A lot of things going on elsewhere at the conference, so after this talk, you might consider checking in on the U room. There's a crypto basics workshop going on that's just up the hallway to the right there, near the bathroom area. Also down on the 6th floor, there's a bunch of workshops. And these are hands-on workshops with small groups, interactive. So these are fun. There's a listing of them on the website. That's not in the printed program. It's on the website, and we have some signage for the workshops as well. And of course, there's a lot of other workshops going on the 2nd floor, vendors and all kinds of things. I'll remind you again, please make sure your cell phone is put on mute so we don't disturb too many of our neighbors. And otherwise, have a great time. Up next is apophenia, which is a word that I didn't hear very much of until maybe the previous event when Will did a talk on sort of a related thing. So I think we're all concerned about this because we're all going to be dead someday. We think there's a theory.
Eventually.
There's other theories, but let's hear about what happens after the fact.
Thank you. Okay. Can you guys hear me okay? I have a tendency to bounce around when I talk. Does that work for everybody? Okay. I'll try to pick up the voice a little bit. My name's Will, by the way, Will Lindsay. I'll tell you a little bit about this ghost machine business and why I'm involved with it. This is related to a talk that happened at Hope Number 9. Hope Number 9, the talk was called Building Radios to Talk to the Dead. And about a year before Hope Number 9, I got involved in this. This is still fairly new to me, 3 or 4 years now. That talk was specifically about analog radio, and I found a whole culture of people online, a large international group of people who were changing, bending, breaking, hacking radios in order to communicate with the dead. I'd never heard anything like that in my life. I thought it was pretty interesting. Shortly thereafter, I realized that this thing they were doing, it's called EVP, Electronic Voice Phenomena. And the idea is that somehow spirits or ghosts are controlling the electrons or the electromagnetic energy around us and making voices come out. So you can actually talk to the deceased or at least listen to the deceased. I found out during that time, I thought this is amazing, but it turned out it's just a small sliver of a larger idea. That idea, or EVP, I'm sorry, electronic voice phenomena, is actually a subsection of something that many, many more people practice throughout the world called instrumental transcommunication. I'm going to refer to that as ITC throughout the talk, instrumental transcommunication. It is what it sounds like, and it's a pretty vague term to cover a lot of ideas. The basic idea is some sort of electronic device or analog or digital device that's being used to facilitate this conversation past the grave. There's something that's when this is really a two-way conversation. This is people that want to have a conversation. This isn't a broadcast from beyond. It's a two-way thing. Something that is commonly believed, to the best of my understanding, is that folks who have passed occupy roughly the same space we're in, but maybe in a different plane, so they can already hear us. I don't know how, but they already hear and understand us, right? And this is commonly believed throughout. However, we aren't smart enough, or we don't have the technology yet to understand communication in the opposite direction. So a lot of these devices that I'm going to show you today are going to seem like they're one-way communication, but the idea is usually the people using them are talking to the air, talking to space in hopes that there's a continuous conversation happening. Let me talk about me for a second and how I got involved in this. I'm a teacher by trade. I'm an artist. I do something called research art. So I base my art practice, performance, gallery work off of research of real things I found in history or real social groups, things like that. All of my work, for as long as I've been doing this in all different fields, is about our relationship with technology. Specifically, I'm interested in how does technology change us as a society? How does it change our culture? How do we change the technology? I'm especially interested in groups that subvert technology, right? So a technology comes along and somebody designs it and it has an intended purpose, and then you have a bunch of people, probably half the people in this room, who want to change it and do something completely different with it. That's really fascinating to me. I've done work on the past with 8-bit music, kind of like the concerts that are going to happen tonight and tomorrow night. People who are hacking video games to make music, unintended purpose, that's fabulous. What else? Hackers, obviously, bending radios and computers and things like that to talk to the dead. What I like to do is I educate myself about these systems. I do it fairly agnostically. I don't necessarily agree or disagree with what's going on. I just kind of take it all in. I then like to take these tools and open them up, create some open source packages so that other artists, experimenters, hackers can then use these tools, right? And then I also use them for my own exhibition and performances. I'll show you a little bit of that if we have time at the end. First, let me talk about this word apophenia. So the name of this talk, and this is also what I've named the body of work that I'm working on right now. Some people in Signal and crypto may know this word already. Apophenia is the idea that people have the ability to take complete randomness and organize it and get meaning from it. So we extract meaning from completely random data sets. It's kind of an amazing thing. It's just something I think our brain has to do to cope, right? And for an example of that, everybody's probably seen this picture before. This is the face on Mars. And we all know consciously there's probably not a giant head glued to the side of Mars. But when we see those specific shapes, we want to make meaning of it. And so we believe it's a face. Faces are probably one of the most dominant things that come through in this apophenia. It's one of the things we are most likely to recognize, or one of the ways that we most want to make sense of what's around us. Clouds, I don't know how that looks on the projector. That could be either a bunny or a duck or a cloud, depending on your position, I guess. I'm barely sure what this is. This is actually folks that work on ITC came up with this. This is smoke reflected through a lantern onto water in a metal dish, or a horse, I guess, or a dog, or a strange picture. I don't know. Apophenia. So let me talk about the history of this a little bit. In my last talk, I talked specifically about the history of the radio side of things, and I want to talk more about the networking tools that we've used and how that they got used for ghost communications, and a little bit about computers and then what's happening in contemporary time right now. I'm going to jump back to, let's see in my notes here, 1921. I'm just going to pull a couple examples out of history and just kind of tell you the stories of what happened with these. This gentleman named F.R. Melton, he was a radio operator in World War I. He lived in Nottingham, England. He published this design in a magazine called Light Magazine. I've not seen the whole issue. I've just seen scans of this design. He referred to this as a psychic telephone. And what Melton realized with his radio, and radio operators, I know there's some amateurs in the crowd out here probably already recognize this. When you're not transmitting or receiving, you want to detach that giant antenna that's going out of your house or the building you're working in case there's lightning or static or something like that. Get it off the radio. And he realized that when he detached his antenna, he could still receive signals. Now, there's a lot of different theories on how that could possibly happen. In New York City, I think it's overload from the AM stations, right? But out in the middle of nowhere, it may be something completely different. Melton, based on where he was and what he knew about radio, theorized that the broadcast must be coming from in the room he was in, right? And the only explanation that he could decide from that point is that perhaps somebody occupying another plane in the same space, or the dead from beyond the grave, right? So he started taking that radio and tweaking it and tweaking the design of it to figure out what worked best to get this two-way communication going. And this is the design that he finally ended up with and published. Kind of an interesting one. Again, the output communication is yelling in the room, right? So there doesn't necessarily need to be a transmission. This is mostly about receiving in this device. D is the headphones, right? F is the jack to plug in the headphones, and E is a power source. I guess they used some dry cell batteries back then. He lists as a transmitter, and I believe this is an analog receiver, kind of like a microphone or something you would see on an old Victrola, that could vibrate with physical vibrations, not necessarily a radio transmitter. B is a balloon. I thought that was kind of an interesting part of the design. And then there's a little spring holding the whole works together. So something to do with the balloon expanding and contracting. And he believed that the spirits could manipulate that and then cause some kind of voices or sound to come through. I don't really know what happened to his research or why he quit or why we don't all have one of these in our house right now. Hard to say with some of these that I'll be talking about. This guy, let's see, I'm going to jump forward in history a little bit to 1940. This picture was taken much later. This is Gilbert Wright. He was a researcher for GE. Maybe somebody in the room might recognize his name. Apparently in 1943 he invented or patented silly putty, also working for GE. Silicon putty. So this is the guy responsible for that. I'm getting this secondhand through information in a very reliable source, a magazine called Fate magazine. This is an article that he was involved with in 1963. This was published, but it's about things that he did in the 40s. Apparently he attended a seance, not too uncommon in that World War II era. Seances at the time, instead of having devices or radios or things to talk to the dead, would have a person who would channel that energy. Very questionable, which is why I think a lot of people started chasing these devices. We put our trust in technology, right? People you can't trust, but a computer or a radio or a piece of hardware, that's something we can trust in life. I don't know about that, but they believed it. Anyway, he was at a seance in, I believe this was 1940 when this happened. And the person running the seance was communicating the thoughts of who they believed to be Thomas Edison, right? And it took me quite a while to track down this story. Edison's ghost said there were some designs missing from his notes. And this particular design that you see on the screen, I'll explain it in a second, was lost in a letter that went to some folks working with him. The actual letter was never recovered, but somebody who said they saw the letter then traced this diagram from the letter and redrew it later. So this is about four hands whispered down the lane, or I guess the game of telephone, they say. The meaning may have changed. My understanding of this, M down at the bottom is some sort of microphone, and then on top of this box that the microphone is in is a metal cylinder. The metal cylinder is filled with a chemical. I don't know much about chemistry, but he lists here as potassium permanganate. Beats me. A is an antenna. I'm not sure the relationship between the antenna and the microphone. And when Gilbert Wright and his associate Harry Gardner got this diagram finally, I don't think they understood it either. In fact, he decided to take this design, ignore Thomas Edison, and create his own or their own design. I don't have a picture of their design, but I do have this very vivid description I'll read, which is kind of interesting. Gardner goes on to explain, he had built a sound box 14 inches by 7 inches high. It's lined with a soundproof material. It has a small hole in one side, and it contained a microphone which connected to a loudspeaker. And that loudspeaker could either be in the room or it could in fact be in another room, so some kind of third party could kind of monitor what was going on without the medium necessarily understanding the entirety of it. A medium did have to be present for this, and here's why. He says the idea is that, here's the theory, the sound box could be placed close to a medium, and ectoplasm projected from the solar plexus of the medium would go through the little hole in the box and create a diaphragm, and then the spirits could move that diaphragm, and that would create the voice the microphone would then pick up. Several people watched this happen. Apparently voices came out of it. If you watched my talk in Hope number 9, it turns out some of these people were ventriloquists. I'm not saying that's what happened in this case. But it's questionable, right? And apparently Wright decided to retire before he finished any research on it. So that kind of went nowhere. Oh, a seance. I don't know why I didn't show that picture. This is Coronet Magazine. This is a magazine from 1955. There's a whole series of ideas dealing with telephone. And probably everybody's heard a story about ghosts and telephones. I'll tell one of them. I think it's a fairly interesting one. This particular story was published by Alfred Hitchcock, of course a reliable source, right? Alfred Hitchcock writing this story, but I had actually seen a second version of the story that Hitchcock based this writing on, and so there is some comparison that maybe somewhere back in history where this story began, some people actually told this story as a real thing that happened or real event. This story is about, Arne Gandy, young man in the 1930s, and he goes off to work for a shipping company. The shipping company has him on a boat that goes all over the world. And in 1933, they port in San Francisco. He goes running off the boat to have fun in San Francisco, and the boat leaves without him, right? He writes a letter to his family. The family receives the letter in January 5th, 1934. They received this letter from their son saying, hey, I've been stranded in San Francisco. I don't have my possessions. I have a little bit of money that I was carrying. I don't have any of my personal effects. I'm not really sure what I'm going to do. And they get this letter. 3 a.m., January 10th, on an unlisted phone number to the parents' house, the mother receives a call from a stranger, an unrecognized voice. And so the story goes, the ghost, there I gave it away already. The voice says, will you forgive your son if you promise that he can come home? And he's in a hospital in San Francisco, and there were several other voices that come into the call. And we'll send him home, right? Another voice then interrupts and kind of fades in, and she says, the voice says, here I lie, propped up on pillows, I can't move. And then the line goes dead, right? It turns out that sometime later, the police found his body in San Francisco, and he had drowned in the water there. And an autopsy determined that he had actually died 48 hours before the phone call was made, right? So again, there's a lot of stories like this out there, and some are more questionable than others. I think this is probably one of the odder and maybe more historically embellished stories, which makes it kind of interesting. So many of these stories have happened just specifically about telephone, right, and the analog computer network that was telephone all the way up through the 1980s and 90s. That different researchers have approached this in different ways. They've approached this particular story and tried to analyze it. They've also taken instances where this is happening to other people and try to create some kind of scientific box around it to prove or disprove what is going on here. In this particular case, most people thought because it was an unlisted number, it was pretty unlikely that it would be a prank, right? Though I think anybody who would know that the son was away maybe would know the phone number, so that's questionable. Some people, there was some belief with some of these calls that somebody could make the call from in the house, right? But anybody who remembers analog lines, if you pick it up, you can't really make the phone ring on the other end. Some of you guys probably could, right? But maybe her husband or somebody messing with her couldn't. And you would hear the dial tone, right? And there was no dial tone in this call, it was just voice. Another theory that gets tossed around pretty often is that maybe the person who received the call is psychic, and they are actually channeling their own energies through the phone as an object, right? I don't know if that can be proved or disproved. The main thing that people say goes against that idea is that a lot of these calls are completely random or unprovoked, right? She had no reason to believe at that particular instance that something had happened to her son, other than receiving this letter days and days beforehand. Move forward a little bit. I'm going to talk about a guy named Julius Weinberger in the 1960s. I could not find a picture of him. He was an engineer for RCA. I'm picking on some of the more intelligent people in these stories to talk about what they did for obvious reasons. I couldn't find his picture, so I found one of the patents that his name is on. So this is an RCA patent for some kind of speaker. Most of his patents were listening devices, speakers, speaker arrays, recorders, things like that, which is kind of interesting. Julius Weinberger was at the same time in his shop at home in the evenings working on this Edison idea, some way to communicate with the dead, some way to make a two-way conversation happen. And he realized while he would work late at night in a shop that sometimes the back of his neck would tingle and you get that kind of sketchy feeling, and everyone's probably felt that now and again. He didn't believe that he was causing that nervous response, that his body didn't give him the chill. He believed that ghosts were actually touching him or causing that to happen. And he believed it so much that he thought, if these ghosts could somehow affect my nervous system or my hair follicles even, that maybe this, instead of electricity or electromagnetic energy, should be the line of communication, right? So we're going to communicate with the dead through hair follicles, right? Interesting idea, and I think he's an educated guy, so we got to put a little bit of trust in what he's thinking at the time. He was good enough to not do his research on people. Instead, he did his research on the Venus flytrap. Anybody who knows these plants knows that they have tiny little hairs inside them. It's a set of jaws, and if an insect or something flies in, it'll clamp shut, right? And so he had the idea that maybe this hairs on the Venus flytrap were similar. And he spent a lot of time measuring feedback, putting sensors on the jaws of the Venus flytrap and getting recordings, and then intentionally setting them off with a little toothpick or something like that, and then seeing what the reading is. And then he later kind of figured out that there was this little tiny 20 millivolt charge coming off of these plants right before they were about to close, and that maybe that was the instance when the hairs were being activated. And so he set up something that looks similar to this, and I'll talk about this picture in a second. An electrode on the top and bottom jaw of the Venus flytrap, put the Venus flytrap in a glass enclosure so nothing could interfere with it, or insects or dust couldn't get in there, and then just measured the pulses coming off of it. And he got tiny little pulses over and over. And he believed after a time of watching or listening to these pulses that they seemed to be patterned. They had a pattern to them. A pattern enough that he believed that maybe there was an intelligent force controlling them. And he cites one moment where he was so aggravated with not being able to translate this to Morse code or something that he knew, that he just said, for 5 minutes, don't make any pulses, and it didn't, right? Fortunately, nobody was in the room when that happened. He did get some other people to come see this, and many people did say that these pulses seemed intelligent. Specifically, the Institute for Parapsychology of the Foundation for Research, that sounds like a very important organization. I understand that that was a small arm of Duke University, and Duke went, nah, we're disassociating ourselves. The Institute for Parapsychology sent somebody, and that person said, yeah, it seems like there's intelligent patterns coming from these plants. But he's very old, and he should probably retire and stop working on this. So he did, and nothing more happened to it. This picture I thought was interesting. Some of you may have seen it before. Apparently, Make Magazine published a hack that you could get Venus flytraps to open and close by shoving voltage at them. And I noticed when I was reading the article that they used the exact same points that were in his research. So I don't know if there was some cross-education there, or the research came out with the same answers as to where those electrodes would go. I'm going to jump to 1980, 80 through 92. There's kind of a long space here of when this happened. This is a group, I'm not good with French, I'm going to butcher some German later too. Cercle d'études sur la transcommunication, Luxembourg. I'm going to refer to that as CETL, settle. I'll just call it settle for now. The translation I understand to mean the Transcommunication Study Circle. So it sounds a little more important or big than they really were. But, they had a letterhead and a nice little logo, so it must have been the real deal. They were founded by these two people. This is Maggie and Jules Harsch-Fischbach. This is a later picture from the 80s. They were a little bit younger, but I had a hard time finding pictures of them back then. They used a lot of these different practices. They used a lot of the EVP, the electronic voice phenomena practices that I talked about in the other talk, and they created some new methods and ideas to communicate with the dead. and they did this in an ongoing lab. What they decided over time was that they needed something called a bridge. This bridge was a bridge between here and beyond, and as long as that bridge existed, different devices could probably use that bridge for communication. And they used many different devices all the way up to the radios, the phones, and up through a Commodore 64, which I'll talk about in a little bit. There was some precedence to using computers for this, which is kind of interesting. There's the Commodore 64. There's a bunch of those downstairs in the mezzanine, which is kind of cool. This gentleman, I couldn't find a very good picture of him, Manfred Bowden. This was taken in Radio Luxembourg. He's the guy on the right. Bowden was interested in computers. He was an avid CBer in the 80s. He had a Commodore 64, and he was typing in. You get the magazine, and you have to type in the whole program by hand off the magazine. And he was typing in a biorhythms program. And while he was typing it, he believed the code changed in front of his eyes. And in fact, it happened a few times, and he had somebody to come over and say, "Did you see that? I saw it. Did you see it?" And several people said, "Yes, this really happened." I managed to get this output print, and this is the German I'm going to try to butcher. The underlined sections here, let's see. Ich bin da, I believe, is I am here. Du stirbst. Anybody with German help me with that? Are you dead or you will die? Is it future tense? You will die. Okay, future tense. You will die, Manfred. 1982, an Unfall's accident, right? So somebody was sending him a message through the computer by changing the program while he was typing to say, "You will die." And this happened several times throughout the program. "You will die in an accident." Interesting, he died of a heart attack in 1990. But there it is, so a little bit of evidence of ghosts using computers. I'll jump back to, so he was not associated with Settle, he was elsewhere in Luxembourg. Settle got so good at this, and they developed this bridge and kept the bridge, that ghosts started using their Commodore 64 as a sort of Dropbox. And they would just put they would put text files and images, and they would wake up in the morning, turn on the computer, and, "Oh, look, we received a message from the dead." And I have some examples of that here. This is, now these, the resolution on these images is a little wacky. Settle was producing a journal back in the 80s and 90s, which I understand to be almost like a fanzine that was Xeroxed. So this has been printed, Xeroxed, and then scanned back onto the internet where I found it. Some of these I shot out of a book that I have, but they all pretty much look like this. This is an image from the dead, right? They're sending a photograph. This is, to the right, Hal Roach. Somebody might recognize that name. He's the guy who created Little Rascals, or Our Gang. Looks pretty young in this picture, but apparently when you're dead, you can look as young as you want. So everybody likes to look young when they're dead. This was received in 1992. On the left, there's two women there. One is Janet Meek, and the other one is Nancy Carroll. And if you heard my talk at Hope 9, Meek is a very big name in kind of the hucksterism side of EVP and using the radios. So that name's fairly easy to recognize with people who are part of this community. I say huckster, I guess I shouldn't say it so loudly, but that was my reading on it. He had a text file. Hal Roach left a text file with this one that explains that the women on the left look disembodied because they're coming through a dispassing point to the fourth plane of existence. Apparently there's multiple planes of existence when you die, and this is the fourth one. Here's an image of a man named Yang Foods. He also left some text files with his image that maybe helped them decipher some ways to deal with language between the living and dead. Multiple languages, and then maybe their own languages on the other side. So some confusion there and how to work with that. Some really interesting theories came out when Settle just started to knock out all these pictures that were left on their Commodore. And some things changed from what people believed about EVP. One is, as I mentioned, they believed there had to be a bridge. So there had to be some pipeline of communication that was available that could be used back and forth, right? In order for that pipeline to exist, there had to be something on our side called a contact field. I've had a lot of problems finding a good explanation of a contact field, but what I understand generally is that everyone participating has to have good vibes. They have to feel good about it, they have to believe it, they have to not be sarcastic or agnostic about this, and they have to just feel good that they're talking to the dead. And if that field's not there, it's not going to work, right? This is a general belief. Interesting, I kind of wish that worked with Windows. I've been fighting with my little Windows laptop up here. And maybe if I just felt good about it would work better. That'd be nice. They also believed that you needed something, and again, many people in the room will recognize this for different reasons, stochastic resonance. So this is used in signal theory. Some of the crypto people probably use this a little bit. The idea is if you have a really weak signal, real small signal, and you can't perceive it very well, if you add white noise to it, that signal should modulate with the useful frequencies and in effect amplify itself. At which point you have a slightly amplified signal and you can then filter the white noise back out and get a piece of that information that you couldn't get. You can get that weak signal in a stronger form, or at least a processed form. So you'll see a lot from this period forward about this white noise being part of the process. There has to be some noise in there in order for us to understand better. This is my favorite part of the theories that came out of Settle. The folks at Settle believed that not just any ghost could do this, that in fact it was dead scientists and they were working really hard to communicate with us. So hard, in fact, that they set up a lab, and this is one of a couple images I have of the lab. It's called the Time Stream Space Lab. So this is a space lab. It is on the astral plane of Marduk. I don't know the names for them, but it's on one of the planes there. The lab is run by this lady, I'll say lady, Sweden Salter. Sweden Salter explained in some text files that she is not a dead person from Earth, but she's actually from a planet called Verid. Verid is a parallel planet to Earth, according to these text files. Kind of interesting, to her side is a picture of, I guess on her computer, of a transmission that they are about to send to Earth. And I also found this, which is a transmission that somebody in Germany said they received around that time period. So I think that was the idea there. I don't know if the people who received it were related to Settle or not. Apparently on the planet Verid, they wear fringe, kind of like that. Here's another picture of the lab. This is Sweden Salter and somebody who looks like they're dressed like the KKK in a lab outfit. I don't know exactly why they have to dress like that to do it. So here's some little pieces of history I've spit out, got us up into the 1990s. Of course, there's some contemporary manifestations of that. Some of you may have seen them, but I'm just going to go through a few of them that I've found. Software, right? There's people who are interested in this, who are programmers, and so they created software. This is a particular piece of software called EVP Maker. EVP Maker takes, you can pipe any audio into it on your computer, and it will digitally dice the audio into tenth of a second fragments, and then it will pile it back together in no particular order. And then the idea is that you're supposed to play this while you're trying to communicate with those who've passed, and the ghosts can somehow manipulate the samples, and with maybe some white noise or a little stochastic resonance, you can actually get some communication out of that. I have an audio sample I'll play real quick of what this guy sounds like, so I'm going to hop out of my slideshow here. This is a sample file that the person who wrote it published. This is using 3 different voices run through this processing software. And is during a communication if you hear a little bit of a real person in there. I don't hear much in there, but maybe somebody heard something in there. I understand, talking to people who do this, that this is a trained skill to be able to hear the voices. So a lot of times when you hear these samples, they'll be looped over and over and over, and if you concentrate really hard and listen to a lot of them, you'll actually start hearing voices. Funny how that works. But EVP maker. I mentioned something kind of off the cuff. I said they're put together in no particular order. They're random, right? All the crypto people in here shaking their head, saying not random from a computer. And the folks who did this recognized that, that, you know, our version of random from a computer isn't really random, but there's a seed in there and it's close to random. But people got a little upset about that, and so the folks who use this started publishing circuits online to create external true random generators, right? And the idea with these, and again, I suspect crypto people also want to do the same thing, but the idea here was having this external device was also another place that maybe spirits could manipulate the randomness of it. This is a website called ITC Bridge. You can go to this online right now. They have a continuous stream, which I'll explain in a second. Unfortunately, that stream's been down for about a year. I hope it comes back up soon. This is a very interesting project. ITC Bridge remotely networked a sensor over Ustream and took audio, converted the audio to images via spectrogram. So this is a software program that takes audio and maps different frequencies in the audio over time. So you end up with this kind of waterfall display, either left, right, or up and down, with dots, pixels, images that represent different variables in the frequency or different loudnesses to parts of the frequency, in the hopes to see images coming from the sound. It's not running right now. I'll read the explanation of the last setup they have, and I believe he's going to do the same thing again. The gentleman who set up this website, I'm sorry, his name's Keith Clark. He has a shortwave radio in a shed. Oh, I have a picture of the shed. Shortwave radio in a shed. Instead of being connected to an antenna, the antenna is connected to ground, to earth. There's a condenser microphone approximately 1 inch away from the radio speaker. There's an XLR cable that runs from the microphone 100 feet into the house. That runs into an audio mixer. The audio mixer is just leveling everything out and then outputs to a computer sound card. The computer is filtering some of that sound and maybe getting some of the white noise out of it. I'm not exactly sure what that filtering was intended for. And then it outputs to another computer, which is sending up to Ustream. The idea being that community members at ITC Bridge can work together, all work on the same stream, so there's multiple people looking at the same evidence, right? So there's some comparison of notes to this. And they're invited to record parts of the stream, pull stills off of it, publish images that they find on the stream, and maybe some of that audio. Interestingly, he made it very clear when he set this up that he did not expect there to be any EVP. He did not expect anybody to hear voices. This was for people who have passed, or maybe Time Stream Space Lab, to send pictures, right? Specifically for that purpose. Here's this gets on the edge of pop culture for me. This is called X Paranormal. This piece of software is produced by extremecensus.com. They have a couple of these. You load it up on your PC. It's a Windows-based. It will find your network card and your Wi-Fi, whichever one you have. If you don't have anything plugged into your network, it will use the open jack, and it will try to read any anomalies in the signal where there shouldn't be a signal, which is kind of interesting. I didn't have a terrible amount of success with this one. They published in their adverts, they say it uses live calculations. They say it uses real-time scanning. I guess that's scanning the Wi-Fi port. It tracks something called R-flux. I had to do a little bit of a research, and you can see that flat line on the top in my version of it that says R-flux. RFlux stands for Rapid Singular Flux Quantum, and I understand this in my layman terms to be on the silicon level in computers. There can be minute fluctuations that are not intended by design, and so this is supposed to be tracking those tiny, tiny fluctuations. I read a little bit about flux quantum to see if this was feasible, and apparently it didn't work on my laptop because I don't have a cryogenic cooling package. You have to cool the silicon in order to read these fluctuations. So not a lot of luck with this one on my part. This is another one they produce. The software interface looks like it's not this blurry. It looks like a handheld recorder. The idea is that it can take multiple line inputs or microphone inputs, depending on what you want to plug in. While you're trying to communicate, you can record from various sources. It mixes them together with white noise, again, the stochastic resonance, and then filters that out and produces some kind of voice output from that. I won't give that one too much time. This is, let's see. Oh, of course, there's an app for that, right? We all have smartphones, so there's a bunch of these smartphone apps for ITC. This one is called Ghost Detector app. The author of this one, I have no idea how this one works. I really couldn't get much out of this one. This is a ghost radar. It apparently uses your GPS and Wi-Fi to detect ghosts up to a 9-mile radius. I don't know where 9 miles comes from. There's a microphone, and if you actually see a blip on the radar, you can talk, and it will use voice synthesis to possibly turn the received signals into some kind of voice. I don't know exactly how this one works. I do know how the next one works, and it may be related. This is called EMF meter. This is kind of interesting. Most of our smartphones these days have GPS on them. And part of that GPS package, or the chip that's on there, usually has a magnetometer, a sensor designed to be the compass, right? So we can find magnetic north. Not only can we figure out where we're going from the GPS, but we can figure out where magnetic north is and determine which direction we're facing in any given moment. This app and a lot of these apps apparently untether the magnetic sensor from the GPS sensor. And use it as an EMF detector, EMF electromagnetic frequencies. The interesting thing about this one is I don't know if it was originally designed for ghost hunters, but you can detect your laptop spinning, or a fan, or motors, or computers, or television. So anything that puts out stray electromagnetic energy can be detected by this. And it does seem to work. Here's another version of it. This is called Ghost Catcher Camera. It does exactly the same thing, and when it sees a spike of a certain amount, it will then turn on the microphone and start flickering your camera, and you're invited to kind of run around with your phone in front of you while you're ghost hunting so that maybe you can look at them later and catch a picture of it. That's what's out there right now. There's an app for that. I take this all a little different direction. Right now I'm in the process of pulling these tools together in my own work. I've done a couple exhibitions now using these tools. I wanted to show you a failure first. Folks probably recognize that little black box as a Raspberry Pi. I've been working a lot with the Raspberry Pi. It's very malleable and cheap and nearly disposable. This particular one has a Wi-Fi adapter on it. I use a tool on this, which again, a few people in the room may recognize. It's called Airmon NG. I think most people use this to grab signals off of Wi-Fi, and though we're not supposed to, maybe look for passwords that are floating around on the Wi-Fi. I do something a little different with it. I take the signal off of Airmon that I get in local Wi-Fi systems, and I pipe it through to a program called SOX. This is referred to as a Swiss Army knife of audio. SOX is a fabulous program. You can take anything and pipe it into SOX and get audio out the other end. And then I run the audio into a spectrogram software to see if I can catch some of these images. Anybody who's heard a Wi-Fi signal knows that it's very sharp and sporadic. And what I ended up with from this particular project is mostly just peaks of white and then nothing, and then a peak of white and then a little bit of signal, and that's about it. I want to keep working with it. I think it's an interesting idea. Maybe I should spend some time in New York City where there's a little more Wi-Fi than where I am. Maybe some white noise needs to be added. That always seems to always be the answer. This recently exhibited and is going off to Ireland pretty soon. I refer to this as my Ghost Vox machine. I built it inside the case of an old radio police scanner from the 60s, I believe. Again, a Raspberry Pi inside of here. Little different idea here. This has a small, untuned antenna on no particular frequency with no loop to tune it. Amplified. It's fairly broadband signal I'm capturing. I'm using that signal as basically a random generator. I'm then taking the random bits that I get out of that and I'm mapping it out to phoneme database, right? Phonemes, for folks that are not familiar, are the tiniest part of speech in our language. So not just syllables or letters of the alphabet, but the individual sounds. So t, k, like that, right? Phonemes. I'll play a little piece from this. Kind of interesting output that I got out of this one. It's very chatty. Sometimes over an hour, I think I hear my name. I have a one-syllable name. I'm going to release that setup pretty soon. I'm pretty excited about it. Get some interesting sounds out of this. The other one I have, and I'll move along pretty quickly here. I see we only have probably 10 minutes or so left. Similar untuned antenna going into a propeller microcontroller. This is another microcontroller that doesn't run an operating system. And I have this one taking the random set and using it to basically generate an A-life algorithm to produce an image. And I'm building a series of fairly large LED screens to project this on. This is 3 foot by 4 foot. You can hear the other guy talking away in the background. This is in the same gallery. 50-50 on this one. I haven't seen too many good screaming faces or anything like that. Sometimes it looks like landscape to me. I got one more here I'll show you guys, and in fact, I'll play an old bottle cap. Now, this has been my most successful one, and in fact, I'm rather pleased with it, and I've asked to give a workshop on how to build this. Thank you. And that workshop's going to be running at 4 o'clock today down in the mezzanine. I'll tell you a little more about it. This is a electromagnetic vibration microphone, so both. So it can be a contact mic to detect vibrations on hard surfaces, or there's also a coil in there that bypasses the audio pickup from a microphone and just captures electromagnetic signals, maybe what comes off of our TVs, laptops, things like that. And then I run it into the microphone on a PC, sometimes the PC I'm monitoring. And this will work on either Linux, Mac, Windows. I found software to do it on all of them, and generate images based off that audio. They're very blurry, and they're very small images, and sometimes I think it helps if you stand very far away and squint. This is maybe a room full of people, or a chiptune concert, I'm not sure. I'll let you guys guess. If you really squint at this one, I think there's something in there. I've been fairly pleased with this output, though. I don't do a lot of post-processing to it, so I'll grab the images and then I'll just enlarge them so they're bigger than a postage stamp. Thus a little bit blurry, but again, I think the noise helps a little bit. I've been told that looks like my head with devil horns. I don't know. And my workshop. The workshop's at 4 o'clock. You can build one of these little bottle cap microphones, and I'll help you set up on whatever you're working with to do the waterfall software and capture your own images. Do what you want. Email me. Tell me all about it. I have little kits. They're about $6 is the cost of them. You have to bring your own bottle cap, so you may want to stop and get some Club Mate on the way. It's just a case to hold the whole thing in. The workshop's listed for 3 hours. I'm going to hang out for 3 hours. I suspect if you've never soldered before, this will take you about a half hour. If you've soldered before, you can probably do it in 10 minutes. And I've published the whole thing on the wiki, on the Hope wiki. So if you don't have any interest in this, or there's so many awesome talks going on, you can just grab the parts list and the instructions later and try it yourself. If you do, please email me. Let me know if you catch anything. Or use it in an exhibit or a performance or something like that. I'd love to hear about it. Is it worth questions? Do we have enough time? I don't know. I can't see out there at all, so. Yeah, maybe, if there are questions. Yeah.
So it seems from the historical aspect that the methods of detecting the ghosts progress with technology that is available.
Yeah.
Right? Did you look into compression artifacts of MP3s or something like that?
Yeah.
Did you really strongly compress it? Maybe you can hear some ghosts there.
Yeah, I've actually done process work before I got involved with this project on that exact thing, and it's come to my mind, nobody in this community has gone that direction yet. I'm very interested in it, and you're right, there's a lot of beautiful noise in those when you really compress something. Yeah, it's amazing. Anything else?
So it's not a crystal ball effect, and you're just not concentrating on something and it's emerging from your own time.
I'm sorry, the crystal ball?
Yeah, it's just in other words, it was just a device to focus the attention, and then the unconscious comes.
Yeah, I think the subtle people believe that. I kind of believe it. I think if this is something you really believe works, you could probably do it with a pen. I think you're absolutely right. The technologies and material. I am interested in the fact that a lot of times people who engage with this technology do so because they don't know how it works, which is kind of fascinating, right? So there's already some mysticism. I don't know how to program this. It just does its thing, right? So maybe it does other things too. That's interesting to me, but yeah, I think you're right. I think it could be any technology or object, right? Good, thanks. I see one way in the back, and then I guess I'll let you go. Yeah. Yeah, I actually just did a straight up lookup table, and I ranged the signal coming in to the number of elements in my data table and let it decide. That's all there is to it. I'm using, there's a library on Linux that I'm using for that called Festival, I believe, that's designed for the blind, speech for the blind, right? If anybody has other questions, I'll be at that down in the mezzanine B area. That's not the one near the escalator. I'm going to hang out down there for 3 hours, so if you don't want to build the kit and you just want to ask questions, I'm happy to talk with anybody about this too. Thank you. I'll catch you later. Thanks.
Hello, Hope. Before we get started with the next presentation, a couple of brief announcements. First of all, if you're interested in hanging anything on the walls throughout the conference, you're perfectly welcome to. Just make sure you use the blue painter's tape. If you don't have any, stop by our security desks and we'll give you some. Because any other kind of tape will get us in trouble with this lovely hotel. So blue tape only. There are some high capacity talks coming up, keynotes and that sort of thing. At any point throughout the conference, if a room is filled to capacity and you leave the room, you cannot re-enter the room because someone else will have taken your place by then. So if you don't want to miss out on the end of a talk, don't leave in the middle of it. Beyond that, standard conference rules. Remember the 5-2-1 rule. Every day of a conference, get 5 hours of sleep, 2 square meals, and 1 shower. This is how we take care of ourselves and those around us and those sitting next to us. So without much further ado, I'm very happy to present to you Charles Duan with Hacking the Patent System.
Hi there. Thanks for the introduction. I'm really happy to be here. This is hopefully going to be an interesting talk. I've titled it Hacking the Patent System. It's different from the EFF paper called Hacking the Patent System. Basically, so my name is Charles Dwan. I am the director of the Patent Reform Project in an organization called Public Knowledge. We're an organization that does DC-based advocacy on technology and policy issues. And so I noticed that we have kind of two patent talks back to back. There's another one at 4 o'clock. And that one I think will go into some more of the really specific laws. But I want to use this talk as kind of an appetizer to, what's your appetite in terms of, what are the problems with the patent system and what exactly is going on. And, the one thing that I'm pretty sure most of you have heard of are patent trolls. These are people who, they take these really silly patents on, sending emails or scanning documents, and they make these outrageous demands. They say, like, you have to pay me $1,000 if you use a scanner, or you have to pay me $100,000 if, you send email in this way. And they send these, to a lot of these really small companies that can't afford to fight them. And kind of to top it off, they don't make anything. So, you've got these companies going out there saying to all of you guys, you're not allowed to write computer programs or do all the cool stuff you're doing, and we're not going to give you anything in exchange except for demand letters. This is besides patent trolls. I think a lot of you have heard about some of these patent wars, like the one between Apple and Samsung. These involve more silly patents. Some of the ones on rounded corners you've probably heard of. You've probably heard of the Amazon patent on photography against a white background. So there are a lot of things going on that I think make people in our community think there's something really wrong with the patent system, and there is something really wrong with the patent system. But the other thing I get when I talk to people in these sorts of groups is this sense that this patent system is this arcane thing that I can't understand. I don't know what's going on with it, and I don't know what to do. And it's sort of the sense of hopelessness that there's no way to fix this thing. And this conference is called Hope, so I am here to give you hope. There is something you can do to fix this. With your help and with your work, we'll be able to actually make it better. But in order to do that, we first have to actually understand what's going on. Now, I don't imagine that too many of you do much work in legal policy, but I do imagine that a lot of you know about security. And the way I would encourage you to think about the problems with the patent system is like a security vulnerability. The patent system is basically like a computer system, right? It takes certain inputs, patent applications, it does some processing on it, the patent examiners do some examination on it, and it produces some outputs. It produces patents. And a lot of times, this works okay, and, you get the data that you're expecting, and a lot of times people figure out ways to send, carefully crafted data that gets out results that you're not supposed to be able to get, namely the kinds of silly patents on, rounded corners or sending emails. So, I would encourage you to think about some of the problems in that way, to look at the ways that people are taking advantage of the system in order to get things out of it that they're not really supposed to get out of it. And so, to start off figuring out what that is, we have to look at, how is the patent system supposed to work? The way it's supposed to work is that patents are an exchange between the inventors on the one hand and the public on the other. The inventor, they invent something, they create something new, they spend a lot of time, figuring out how they want to make this product work and how to get it to be useful, and they provide that information to the public. That's the inventor's part of the bargain. And in exchange, the public, through the government, gives the inventor certain rights, certain monopoly rights. They say, all right, since you invented this, you get this patent, you get to do all these special things with it, and you get to keep other people from doing that. So this is meant to be kind of an equal bargain. The inventor has to provide something, the public provides something. And when we look at, what's on both sides of the bargain, the person who receives a patent, they get a lot of rights. You get to, if you own a patent, you get to keep other people from making, from using, from selling, from offering to sell, and selling includes giving away for free, so even offering to give away for free, from selling parts, from telling other people how to use an invention, from importing an invention into the United States, from exporting parts of the invention out of the United States. These are a lot of rights. If you hold a patent and you see somebody else doing any one of those things, you have a reason to go after them and sue them for potentially a lot of money or to tell them to stop doing it. So, the patent is a very, very powerful thing. And in exchange, the patent owner is expected to do a lot of work in order to get that patent. So, the person has to invent something. That invention has to fall within, certain categories of what is allowed to receive a patent. They have to come up with something that's new. They have to come up with something that's non-obvious. These are, these are supposed to be pretty hard tests. There are a lot of things that, you and I would know how to do. You're not supposed to be able to get patents on that because it would be considered obvious. You have to file this really detailed patent application that explains exactly how the thing works, exactly, all of the aspects of it. You have to put in all these drawings. It can be a very expensive and very complicated thing to put together a patent application. And then you have to go to the patent examiner and go through, 2, 3, 5 years of examination and, explain to them why this invention is really interesting. This is a lot of work, and it demands that you have some sort of really good invention. So, that's why we feel it's okay to provide, all of these really powerful rights on the left, because you have to do all of that work on the right, and you have to give something really useful. So, that's how it's supposed to work. But if you want to take advantage of the patent system, your goal would be to try to get as many of those rights as you can on the left side without having to do any of the work on the right side. So we want to see, how do you do that? And the example I'm going to give you is I'm going to show you how to get a patent on this. Okay, this is a 3-line computer program written in BASIC. I'm pretty sure most of you can figure out what it does, but just for people who are only listening, this is a program that compares two numbers. If one of the numbers is less than the number, then the program stops. Otherwise, it subtracts and it adds two numbers. That's it. All right, so obviously you're not supposed to be able to get a patent on that, right? This is a mathematical formula. This is really simple. All of you probably do this all the time. So how do we get a patent on this? Well, first of all, I need to flesh out this program a little bit because this thing wouldn't really work right now. So I'm gonna. Okay, so sorry. Before we talk about that, the way I'm gonna do this is I'm gonna take advantage of a number of cases, and I'm gonna sprinkle the case law in here. And the first case I'm going to start with is this one called Diamond versus Deere, which has a line that says claims have to be considered as a whole. A claim is a part of a patent that defines, what you think you invented. And, this is the part that the courts are going to look at, that the lawyers are going to look at. This is the part that's important to your patent. And the goal is going to be to make this claim as a whole look really complicated, even though it's really only covering this 3-line computer program. So how do we do that? Okay, first of all, I'm gonna say, instead of just saying just random variables, I'm gonna give the variables some names. I'm gonna do this in the banking sector context. So, I'm gonna talk about an account. I'm gonna talk about 2 accounts. So you've got account 1 and account 2. And I'm going to change the variable to exchange. So basically now this is just a little program about exchanging money from one account to another. Everybody see how that works? This should be pretty straightforward. I'm pretty sure that most of you have done this at some point in your life if you've exchanged money with somebody. So we need to declare our variables, right? That is kind of how computer programs work. So we need to do that. Let's put in an input-output statement so that we actually, receive some data, because, you need to know how much money to exchange before you can exchange the money. And, I'll throw in a couple print statements just so, we know what happened. As you can see, all the things I've added, these are just, very conventional things that you would ordinarily do in a computer program just to get the thing to work. Lots of law out there saying that adding these sorts of steps doesn't contribute anything to patentability. And I think all of you would understand that, adding a couple of print statements shouldn't make something patentable. So here we got this computer program, which I've just fleshed out a little bit, but it really is that same program. So starting from here, let's go for writing some real patent language. All right. So we're going to start out with a computer system. We're going to talk about computer system. Computer system, that doesn't sound so complicated. Let's call it a data processing system. Data processing system. What does a data processing system have? Well, it's got a keyboard and it's got a keyboard controller. Something to receive the data from the keyboard. But keyboard, that's kind of a conventional term too. Let's call it a communications controller and a first-party device. Because that sounds a little fancier, right? First-party device, and now, maybe we're talking about some network stuff. It sounds better. Okay, so we've got communications controller, first-party device, coupled to said communications controller. What else does a computer have? It's got a memory, right? But memory, that's kind of conventional. Let's call it a data storage unit, and it's got a CPU. Instead of calling it a CPU, we'll call it a computer, but we'll also mention, by the way, that the computer is coupled to a said data storage unit and said communication controller, just in case you weren't sure that your CPU was connected to your keyboard, right? All right. So now we've got this, and this is a lot of text just to explain what a computer is, right? So why are we spending so much time just explaining what a computer is? Well, it's because we have a number of cases out there. One of which was this case called Bilski versus Kapos. I'm just quoting something out of the Patent Office's guidelines, which says that recitation of a machine or transformation, either express or inherent, weighs in favor of patent eligibility. So that means that if you're talking about a machine, it sounds a whole lot more like it ought to be patentable than if you just talk about an equation. So the more I make this look like a machine, the better a place I seem to be. So as a result, I'm going to spend a lot of time just, explaining, okay, what parts of a computer I have, even though these are all just very generic parts of a computer. All right, so let's move on to what this computer actually does. So you remember we declared our variable, so we'll have a data storage having stored therein a first account balance and a second account balance, right? That reflects the two lines I got there. But first account balance, second, that makes sense. We can't use words that make sense. So we're going to say information about a first party, or information about a first account for a first party, and information about a third account for a second party. But we can flesh that out even more. We can say that the information about the first account for the first party is independent from a second account maintained from a first exchange institution. And the same thing about the second account. Now, all that says is that the information that I am storing in this computer is also somewhere else, right? All I've said is that, this information in the computer, it's also on some other computer. It doesn't add anything to the actual operation of the computer. It doesn't add anything to the complexity of the system. It just says, this is what the data happens to be. There are a lot of Supreme Court cases that say, this stuff doesn't matter, but it makes the thing look really long, so, we like it. All right, what else can we do? Okay, now we're going to get this input statement. So you remember I had this computer that was coupled to the data storage unit and said communication controller because, apparently we didn't know that computers were connected to keyboards. What does this computer do? So we're going to spend a lot of time talking about this very simple algorithm. And the reason for that is that there are a couple of cases that are out there that say that if you spend a lot of time explaining an algorithm, that algorithm turns the computer into this special purpose computer. And because it's a special purpose computer, now suddenly the thing is patentable, whereas a general computer is not. So, there's one case that was actually decided just last year that decided that a patent was, perfectly eligible, and the reason for that was that it required it had a lot of steps, and these steps required intricate and complex computer programming. Now, if any of you actually read that patent, I'll give you a little background on this one. This was a patent on the technology of displaying an ad before watching a video online. How many of you think that that requires intricate and complex computer programming? Now, the lights are off, but I'm pretty sure there are no hands up. Yes, lots of problems there, but we're going to try. We're going to try to make this thing look like it requires intricate and complex computer programming. So how are we going to do that? All right. We're going to receive an exchange amount from the keyboard, right? That was the first thing that we did. We received some data from the keyboard. Receive an exchange amount. We're going to say receive a transaction, because transaction, that's kind of a fancy thing, right? And this part about being from the keyboard, remember we didn't call it a keyboard, we call it a first-party device. And just in case you forget, we're going to receive it via the communications controller. So now we've got the actual steps of of comparing the data. And so a simple way of explaining that, which I put up on the screen, is we adjust the accounts based on the transaction. We call it a transaction, so I'll call it a transaction again. If the accounts have sufficient balances, right? So we're going to do a comparison to see if it has the accounts have sufficient balances, and then if they do, we're going to adjust the accounts, right? This makes sense, which means that we have to fix it. Instead of saying just adjust the accounts, let's say electronically adjust the first account and the third account, because instead of just saying accounts, we can list them, and that adds more words. Based on the transaction, that's a very simple way of saying things. Let's say in order to effect an exchange obligation arising from said transaction. You see, I've introduced this new term, right? Exchange obligation. What's an exchange obligation? Well, you have to do the exchange. Well, what's the computer going to do? It's going to do the exchange. So all I've done is really introduced a term that describes what is happening. Again, it's not any real substance to this, but it does make it seem like there's more going on. And then, I'll mention again that it's between the first party and the second party, simply because I can. And then this part about if the accounts have sufficient balances, that's again, very simple. So instead, we're going to say, after ensuring that said first party and or said second party have adequate value in said first account and or said third account respectively. Read through that again, and you'll notice that all that's really saying is just compare two numbers. But, this sounds like it's a pretty complicated operation, because of the fact that they say and or there, which, means that you could do it that way, or you could compare some other numbers. It sounds